thank you for coming back. Are you noticing a theme developing here? If you've been attending the talks, especially in this main hall, you're beginning to hear over and over again how important mobile is to web developers. I started the day talking about how important it is in terms of app cache and local storage. And then we had Nokia up, and of course they're going to say mobile is important. You can't blame them for that, can you? Of course RIM is going to say mobile is important. That's where they live. But to have Google say it's not okay to ignore mobile devices anymore. Historically, we've been able to get away with that because mobile devices didn't really render HTML. Mobile devices supported WAP and WML. And there was a very, very sparse user experience. It was not nearly as rich as the full HTML5 experience. That is no longer the case anymore. We have smartphones, we have tablets, and I keep saying this, I'm doing smart TV development right now, where all of a sudden we're going to have HTML that needs to look just as good on your smartphone as it does on your tablet, as it does on your desktop computer, as it does on your television in your family room. This is not a hyperbole or mythology. This is very shortly going to be the reality of the situation. People are going to be viewing this content across multiple screens. So you are absolutely beginning to pick up on this theme that mobile isn't something we can continue to ignore. I hope you're accepting it and believing it. So this talk, while not mobile specific, again is very mobile friendly. What we're going to be talking about is a single page application, or other ways to explain it as a client-side MVC. How many of you in here are used to doing server-side MVC development? Absolutely. I'm raising my hands as well. I've written books on JBoss, so I'm very comfortable with Java server-side development. I've done Microsoft server-side development. Even in Groovy and Grails, the books I've written are all server-side MVC frameworks, Model View Controller. This is a very different way to do application development. I'm not afraid to tell you I've been struggling with it because I've been dipped in server-side MVC for so many years that it's very natural. I don't have to think about it anymore. This forces you to look at the way you architect your application in a very different way. Now, I'm not trying to scare you away. Please lock the doors. I don't want anyone to run out on me. You can handle it. You're a very smart group. Who here isn't smart? Who here isn't going to be able to keep up with me? That's right. You're all smart enough to deal with this. But this is going to be a very different approach to web development than you might be used to. Normally, when you start looking at tutorials on Backbone, they dive immediately into the syntax. And I find it very jarring because I don't have the architectural underpinnings to really appreciate what the syntax is doing. So I promise you, we're going to show you live code. I'm going to show you lots of Backbone syntax. But if you will indulge me, for the first portion of this talk, I want to talk about the architectural underpinnings of Backbone. So when I do show you code, you'll have a better understanding of what that code is trying to accomplish. Is that a fair trade? Yeah. Excellent. Okay, good. So this is straight from Backbone's website. When I see their website, they say Backbone gives structure to web applications by providing models and collections and views. Okay, we're all familiar with these terms, yes. But the reason I am highlighting these terms is there are quite literally 4 classes in Backbone. That's it. Backbone is an incredibly lean API. It is less than 1,000 lines of code. I want you to stop and think about that for a moment. Less than 1,000 lines of code. So it's a very easy API to kind of read the source code start to finish. So I told you there are 4 key objects right there. We only see 3 of them circled on the screen, don't we? All right, in Model View Controller land, we have models, we have views, we have collections, and yes, the fourth in Backbone is called a router, but in fact the router is your controller. As a matter of fact, in previous versions of Backbone, it was called a controller. They only recently changed that name to router. Don't ask me why. I don't know. But what we have now is a model, a view, a router, and a collection of models as well. Yeah? So I told you it's a very light API. As a Java developer, I very rarely worry about the size of the jars I'm including. I'll have a JDBC jar in there. I'll have a Hibernate jar. I'll load up my jars. My application can be tens, if not hundreds of megabytes, and I don't worry about that. Because as a server-side Java developer, that code doesn't have to be transferred to the end user. All the heavy lifting happens on the server, and it's only the result, the HTML, through a JSP page, or an ASP page, or a PHP page, or a Ruby on Rails ERB page. It doesn't matter. All the logic is on the server, and since you're deploying to the server, you can have your application be as large as you want. The smallest Grails application, I think, clocks in at about 27 or 28 megabytes. Deploying to the server, I don't think twice about it. Would you want to download 28 megabytes to every user every time they visited your website? Not at all. But with JavaScript, things are different. This is a client-side MVC framework, and so we are downloading the framework every single time. So I am thrilled to see that the production version of Backbone weighs in at a whopping 5 kilobytes, not megabytes. It's a very, very light framework. It really only has one hard dependency, which is _JS. That, too, is a very small library on the order of about 4K or so. So we're not adding a lot of heavy weight to our applications. Now, there's one more core library you're going to need if you're doing any kind of AJAX calls, and believe me, you're going to be doing AJAX calls. So you can use jQuery. How many of you in here use jQuery right now? Very popular framework, isn't it? The only problem with jQuery is it's evolved to a bit of a kitchen sink, isn't it? It's had one too many cookies after midnight. It's beginning to pack on a lot of weight. How many of you in here are familiar with a library called Zepto? Has anyone heard of that? Oh, very good, very good. So you know about Zepto, you know about Zepto. Zepto is a library that is API compatible with jQuery, but it is targeted at mobile devices. And so again, as a mobile developer, if you're trying to write a Backbone app, Zepto comes in at about 4K as well. So as a mobile developer, I look at Backbone, 4K, 5K. I look at _4K. I look at Zepto. Those are all entirely appropriate file sizes. They'll be downloaded very quickly and stored locally on a mobile device. If you do want to continue to use jQuery, there's nothing wrong with that. And for desktop browsers, that's exactly what I do. So, before we get into the code, and I promise you I will show you code here, let me put some circles and squares and arrows on the screen so we can understand where we're going with this. And what we want to understand first is what a traditional multi-page web application looks like. That's what you've been doing in Java, in ASP.NET, in Ruby on Rails, and PHP, a multi-page app versus a single-page app. And these are well named. A multi-page app is exactly what it sounds like. I have an index.html page, and on that page there'll be a link, and when the user clicks on that link, it'll download grid.html, and when they click on something in that grid, they'll download details HTML. And so every time you click on a link, you're generating a new HTTP request. Every time you type in a search value and click on submit, you're round-tripping to the server, letting the server accumulate the results and send the results back down to you. There's nothing wrong with this, by the way. I think for many apps, this is still absolutely entirely appropriate. But sometimes you don't want to generate this traffic. I talked a lot this morning about having airplane mode applications where I'm on my smartphone and I flip it into airplane mode. I turn off the network connectivity and I still want to have a fully functioning web application. We can't continue to generate HTTP GET requests each time in order for that to work, can we? So this is where single page apps work. And even though I'm going to be using Backbone as my particular implementation here, there are a number of mobile MVC frameworks available to you. If you don't use Backbone, you might use Sencha Touch. If you don't use Sencha Touch, you might use jQuery Mobile. If you don't use jQuery Mobile, you might use Sprout Core. There are a number of different libraries out there. But what is common among all those libraries is each page, in quotes, is in fact a div. When we're talking about a single page app, we are talking about a single page app that contains multiple divs, and as you click on that link for grid, what it does is it hides the index div and displays the grid div. And when you click on an item inside of that grid, it hides the grid div and displays the details div. Does this make sense? Yes, absolutely. But can you see how this is very different architecturally than what you might be used to dealing with? Absolutely, absolutely. You might say to yourself, well, wait a second. If you have to download all of that information, isn't that a larger payload? And it is initially. But once you have that entire content there, your app is incredibly responsive. Because it's expensive round-tripping to the server every time. It is instantaneous to show and hide a div locally. So if you want to improve the performance of your app, even if you're on a desktop, even if you never plan on getting into airplane mode, taking this single page architectural metaphor will dramatically improve the responsiveness of your application. Because after it's all downloaded, it's local, and you can show and hide divs for free all day long. The second idea I want to talk about here is the difference between server-side MVC and client-side MVC. So as I said, if I go to Google or Yahoo or Bing or insert the name of your popular search engine here, when I type in a value and click on submit, that's going to generate an HTTP GET request up to the server. The server is then most likely going to have a controller, and we know the role of a controller in an MVC app is to handle all incoming requests and put responses on the wire. So absolutely our controller is going to catch that request. It's going to go look for the results in a database. Of course, that could be a relational database. It could be a NoSQL database like MongoDB, Cassandra, CouchDB. It could even generate additional web services calls behind the scenes and get it from a federated server somewhere behind the firewall. It doesn't matter. Conceptually, what it's doing is it's going to the persistent store and generating a number of models for us. Either a single model or most likely, in this case, since I'm searching for something as popular as JavaScript, a collection of models. Models, of course, are meant to be view agnostic. Models are meant to be pure data with no HTML wrapped in it. And this is so we can reuse these components. If it's pure data, then it means that one of my views could be HTML. Another one of my views could be ASP. Another one of my views could be JSP. Another one of my views could be a rich desktop client that's going to render it in Swing or anything like that. So it's really important that our models are pure data and our views are pure presentation. And by having this clean separation of concerns, the controller gets the request, it materializes the model or the collection of models for us. The models are handed off to the view, and it's the result that gets handed back down to the client. Yeah? Excellent. So now let's look at what this looks like from a client-side MVC perspective. And one of the first things you'll notice is when I click on a link, I'm not going to go server-side at all. I am going to show or hide the appropriate div. So I do still have a controller. Again, Backbone calls it a router, but this is local to the client. Now, it's the role of the controller to materialize these models. This is where your server-side traffic is going to happen. At Time Warner Cable, when someone says, show me today's television shows, we make one round trip to the cable set-top box, which returns JSON to us, and then we use local storage to persist that. Round tripping to a server is expensive. And so if we can then materialize our models out of local storage instead of round tripping to the set-top box every time, again, performance goes up dramatically. So you do have to make these requests once. You don't have to make them a second or a third or a fourth or a 100th time if you're intelligent about intelligently, dare I say it, aggressively caching this data on the client side. But let's say we did have to search. We did have to go to a server. The server did whatever it did. I don't care at this point. All I know is that it returned JSON to me, JavaScript object notation. So I now have a model or a collection of models locally. I then hand it off to a view. There are a number of templating libraries in JavaScript. Now, in ASP, you know that you write your ASP pages. It's mostly HTML with plug points for your data to fit in. If you're a Java developer, you write JSPs. Those are templating libraries. There are a number of templating libraries for client-side JavaScript as well. Underscore gives you templating for free. I end up using that since I have to include underscore anyway. But if you don't like underscore as a templating library, you can use handlebars.js. If you don't like handlebars, you can use Mustache. If you don't like Mustache, you can use jQuery templates. There are a number of different client-side templating libraries, and thankfully, Backbone is completely agnostic to that. So you're free to use whatever templating library you would like. But this is what the life cycle of a client-side MVC application looks like. So the third thing I want to talk about is the difference between taking a page-centric approach to web development and a component-oriented approach. So now a page-centric approach, and this is pseudocode up here, but I wanted to at least illustrate the point that let's say I wanted to build up this page on the server. What I would end up doing is saying, okay, what I want to do is I want to grab this sidebar and then append all my list items to it, and then I want to grab this movies div and append all my items to it. You can see what we're doing server-side is we're building up this HTML, but it's very proscriptive. It's me painting these elements onto the page and then handing the result down to the client. This is a page-centric approach. You draw out the page and send down the results. A component-oriented approach takes a very different perspective. As the name implies, a component-oriented approach says, I have components on a page. I have a sidebar component. I have a grid component right here. And so what I want to do is just new up these components. New sidebar, new grid. And it's these components that are responsible for their own life cycle. It's the grid component that's responsible for painting itself on the screen. It's the sidebar component that's responsible for painting itself on the screen. And typically what we will do is we'll be very event-driven here as well. So as I click on an element in the sidebar, I have a listener on that that will react to those kinds of changes. How many of you in here have done any Google Maps development at all? You are already component-oriented programmers right there, aren't you? You don't say, all right, I'm going to get my hands on the map div, and then I'm going to paint this map tile here, and this map tile here, and this map tile here, and I'm going to draw this line, and I'm going to apply this button to all. No, absolutely not. You say map equals new Google map. And then you're hands off at that point. The Google Map is responsible, the Google Map component is responsible for its own lifecycle events. When you click and drag in the map, it's the component that's doing those kinds of things, reacting to the clicks, doing the event listener stuff that we're talking about. So if you've already been doing Google Maps type development, you've already been doing this kind of stuff. But it is very different than the way I would approach this in Grails, in JBoss, in struts, in any of those kinds of frameworks. Now, the last thing we want to talk about here is the synchronous versus asynchronous nature. And this, I think, is maybe the hardest thing I had myself getting my arms wrapped around. Because I had done Google Maps development. I've written books on Google Maps. I get that. MVC makes sense. I'm comfortable showing and hiding divs. This is all good. But this, if I have a bug in my application, 9 times out of 10, it's because I'm thinking in a synchronous way instead of an asynchronous way. A synchronous approach would be, all right, I'm going to get menu items and then write them to the sidebar and get my movies and write them out and get this and get this and get this. And if you're doing server-side development, it's entirely appropriate to do this because you're going to paint the entire page, and when you're done, the fully rendered response is what gets sent back down to the client. So this is entirely appropriate. I'm not suggesting you're doing it wrong by any stretch. But in a client-side application, when we're dealing with asynchronous events, this is going to require you to solve these problems in a slightly different way. I'm now beginning to show you Backbone code here. Don't worry, we're going to go in and we're going to live code this stuff, so we're going to see a lot more of this. But we're beginning now to inch towards real implementations rather than circles and squares on the screen. So I told you Backbone has 4 key elements: a collection, a model, a view, and a router. Now, we're not seeing routers and models here, but we are seeing collections and views. So when I new up a new Backbone collection, one of the first things I do is I tell it what this collection is going to contain. In this case, my movie list collection is going to contain a list of movie models. The only other thing I have to do is give my collection a URL to where it needs to fetch that JSON data from. And notice that's it. I don't write anything else about, here's how I want you to go out and fetch it, and here's how I want to assemble this, and here I want to do this. No, you just say, this is your list of models, here is the URL where you fetch your data, and you're done. Okay. Now this is pure data up here. Now let's look at a view. Well, a view has an initialization function. Think of this as a constructor in your view. And what I'm saying is, on reset, let's call add all. Now, on reset of the collection. So when the collection triggers this reset event, I'm listening to it right now, and I am going to call the add all function. And it's the add all function that renders the list, draws out the LIs, and does things like that. But nothing happens yet. Nothing happens until I new up that list, I new up the view, and pass in the collection. Notice this named key value pair collection corresponds to this dot collection up here. And when that collection triggers a reset, and that happens when I call fetch. When I call list.fetch, it generates the AJAX request, all that data is downloaded, and once it's fully downloaded, it throws a reset event. And whatever component is listening to that reset event will then have a hook to its own method to do this. And you can see by the very decoupled nature of this, I might have multiple views that are listening to that same reset event. I might have a grid view that's listening, and I might have a details view that was listening. I might have a title bar item, things like that. When I call fetch on the collection, as soon as it's done, it throws an event, and whoever is registered to that event reacts, and they begin painting themselves. I'm going to pause here for a dramatic effect while you absorb that. Because this is Backbone in a nutshell right here. Everything we've been talking about, Backbone is a single page app. It's a client MVC app. It is a component-oriented app. And everything you do is asynchronous. Does this make sense? Excellent. Excellent. Now we get the green light. Now we get to the good part, right? Show me the code. Yes. And so if you want this code, all of my code is available up on GitHub. If you go to check 1, 2. Yeah? Oh, here we go. Thank you very much. If you go to github.com, and my username up there is ScottDavis99. If you look on github.com for ScottDavis99, this is where I'm storing all of my slides for all my presentations and all of my source code for my presentations as well. So once again, if you go to github.com/ScottDavis99, you'll be able to download the Backtube project. Because what this is a demonstration of Backbone making a call to YouTube's set of public APIs. So this will certainly evolve over time. The one thing this app doesn't do right now is actually play videos. But that's okay. Because what it does do is demonstrates all the key pieces of Backtube. I don't plan on ever commercializing this or anything. What I say in my efforts right here is this is my effort to get inside of Backbone's head to really understand it. And one of the things I wanted to do is not write an application that depended on a database or local storage or IndexedDB or any kind of persistence mechanism. I wanted one that was purely driven based on web services. And so I'm using YouTube's public web services and Backbone's client-side MVC framework. And rather than calling this app Ubone, which would get me banned from many conferences, I decided to call it Backtube instead. So, shall we take a look at the code? Actually, before we look at the code, let me at least demonstrate to you what's going on. Now, I wasn't able to get an internet connection going here live, so the one thing we're missing out of this are the pretty box art, the pretty movie images in there, but that's not important. The important thing is that I have a way to flip among several different views, a text view, a list view, and a grid view as I'm clicking around. The other thing I won't be able to demonstrate for you today, unfortunately, is pagination, because I'm just serving up static JSON from here. If I were making calls to the live YouTube web service, I'd be able to demonstrate page 1 of this, page 2, page 3, page 4. But the important thing out of all this is for us to recognize that this is a component. And as a matter of fact, each one of these individual elements is a component. So this right here is a component. The entire collection of those is a component. This pagination set of elements is a component. And then this view flipper is a component as well. So we have a number of different components out here. As I click on this button, that throws an event. I have a view listening to that event, and that view will actually apply a different template. And as I click again, and as I click again. So this is how the app behaves. Let's see how it was implemented. So to begin, let's look at index.html. It's a very good place to start, isn't it? Stretch this out a little bit. There we go. So in Backtube right here, you can see the first thing I'm doing is I'm downloading the scripts. I need to download jQuery. I could use Zepto as well if I wanted to. I need to download underscore. I need to download Backbone. Those are my 3 libraries, 5K, 4K, and unfortunately 180K. But then I have my application written here in Backtube.js. So these are my 4 dependencies. You'll notice that I've got some templates here. I'm happy to use underscore templates because that's already included in underscore. We'll get to the templates in just a moment here. I have my good old document ready. All you jQuery folks are saying, finally, something that looks familiar, right? Yes, on document ready, you can see what I'm doing. I'm newing up a new movie list, newing up a new view, just like we saw in the slide deck, passing that collection to that view. I'm also newing up a sidebar view and passing in a couple of things to that. I'm newing up a router, and then I call start. So this is very idiomatic Backbone right here. New up your particular elements and then call start, and away you go. Ironically, my application itself is incredibly lean, isn't it? Essentially, all I've done here is I've got a couple of divs. I'm using HTML5 sections, but the same idea here. You can think of these as divs. I've got a sidebar div and a content div. And that's it. What I'm going to do now is begin painting my components into these divs and letting the fun begin. So then, let's take a look at Backtube.js. Here we go. We'll start with my router. And as I said, my router is the controller in this application. This is what's listening for all of those clicks. So I'm not doing a bunch of routing right now in here, but I did set up this arbitrary route. Let's say that I was able to click on comedy in the header right there. What happens is these are a series of key value pairs. This is the route, and this is the route handler. And so when someone calls for comedy, clicks on a link that links them to comedy, it'll call the comedy handler. Comedy handler in here will say, hey, I am now watching a comedy. So if I come over here to Backtube, and rather than typing it up here, if I had clicked on a link going to hash comedy, we can see that I am now watching a comedy. Right? Because I'm a client-side app, you'll see these URLs begin with hashes. We know that, right? We know that as web developers that anything after a hash is meant to point to internal divs to the web page, not going to generate a new HTTP request. So this shouldn't surprise us that this is how Backbone has implemented itself as well. So now if I were to go someplace else, if I were to go to foo, which doesn't exist, well, it's a no-op. It generated a mere 450 errors under the covers there. That's mostly because I don't have an internet connection. But if I wanted to implement this foo, look at me doing live coding just to prove to you that I'm not making this up. Here is the foo route, and here is my function alert Hello Kids 2012, right? The only other thing I have to do now is say when foo is called, let the foo handler handle the foo. Come back in here, do a quick refresh. Uh-oh, this doesn't bode well here. Oh boy, what did I do? Let's see here. Thank you very much. Yes, there's a comma. If you go to Venkat's CoffeeScript talk, he will demonstrate to you why those commas are annoying. I'm a big fan of CoffeeScript as well. So now what happens if I go to hash foo, I can see hello kids 2012. So the router is probably the least interesting bit of these things. Let's move on now to models. Isn't this something? Isn't this something that my model is empty? This is the entirety of my movie model. Because JavaScript is a dynamic language, it means whatever JSON I get back from YouTube, I can just pour into that model, and that model then immediately adapts itself. I use this, and by the way, this is idiomatic Backbone as well, because as I'm dealing with Backbone, I could point Backbone from YouTube to the Netflix API. I could point it from Netflix to the Time Warner Cable API or my own personal API, and really I'm not concerned about the implementation details. I just want to say this thing is a movie, and whatever JSON you pour in is what's going to get rendered. So while the model is quite simple, the collection is where the interesting bits happen. The first thing I need to say is, hey, guess what? Your model is a movie. And you can see where normally I would be making a call out to YouTube. I've commented that out. This URL now is back here to localhost where I'm serving up static JSON. This is why I won't be able to demonstrate pagination to you. This is just a flat file on disk. If we want to see what this looks like, this is it right here. If I were making that request to YouTube, this is what would come back. I did a quick curl at the hotel this morning to make sure I had this information cached up locally for me. Now, normally, I could just hand off any JSON and have it work, but you'll see that this particular API has some metadata that I don't necessarily care about, certainly don't care about in terms of displaying to the end user. I don't care about the API version. I do care about the data, but I don't necessarily care about all of this stuff. I want to get straight to the items, and then this is what my item looks like. This block right here is what gets poured into my model. So I have uploaded, updated category, title, and a description. And if I look a little bit farther down, I have additional JSON, and I didn't pretty format that stuff, just so we saw what was going on. The important thing here is I need to get to items before I start displaying those things. So if I look at my movie list collection, I tell it what my model is, I tell it what my URL is, and then optionally I can pass it a parse method. And in this parse method, I can say, please return the response data items as my list of movies. Response data items is my actual collection. Again, very lean, very easy to understand. I have some next and previous functions for pagination. You can see this is definitely a work in progress, right? But for pagination and jump to, the important thing for us to recognize is we now have a router under our belt, we now have a model under our belt, we now have collections. So let's focus on views, the fourth element of Backbone. Now, this is what a movie view is going to look like. This is an individual movie, Talladega Nights, Life in a Day, Year One, Home, Groundhog Day. And you can see that what I'm able to do in this view is say, I want you to be stored in an LI. This is an element that doesn't exist, so Backbone is going to generate a new LI element. And then on the render call, what I'm going to do is I'm going to grab a template, and I'm going to append that template to this element. What does that template look like? Well, this is what I skipped over in index.html. I have a number of templates up in here, and if we wanted to see what the movie text-only template looks like, you can see it would be an article with a simple H2 and a title and an ID in it. So this is what it looks like in text mode. Just an H2, yes. If I wanted to see what that would look like where are we at here? There we go. That was right in front of me. A grid view right here. Then a grid view is going to have a little bit more. I missed not having that image there, but this is what the grid view would end up looking like. So that would be a list of titles and images. And then what my list template looks like is an H2 with a title, with a paragraph in it, with the description and all these kinds of things. So as I'm flipping back and forth between the browser and the source code, can you see what's going on with this? Yeah? And as I said, This templating language that I'm only using because I'm a lazy developer. A great attribute of all developers. Use what's already there and be done with it. At Time Warner Cable, we were using jQuery templates before we were using Backbone. So it was wonderful. We had this huge body of source code that we had already in place, and I wasn't looking forward to having to rewrite it. So what we did is we said, we're going to go ahead and carry along jQuery templates. So having that flexibility to swap out those elements is a huge benefit to what we're dealing with here. So when I come back and see what's going on, we can see that my movie templates in here, the reason why I have a bunch of these switches is either if you pass in a template, I want you to use that template, and if you don't, I want you to default to that grid template. And that's why there's a little bit more going on here with this template, choosing the particular template and applying it that way. So, do you see the various pieces working together out of this? Yeah, absolutely. Now the fact that I am calling to YouTube's API would, I've got a red bar now. All right, I think I ran out of batteries. I don't talk that much, do I, to run out batteries on a microphone? Oh, goodness, okay. But as you begin seeing all these pieces work together here, we begin seeing that each component does its very own thing. The view is just responsible for rendering items to the screen. The controller, the router, is just responsible for handling various routing requests. Thank you very much. The collection is responsible for making those JSON requests and pulling them down and parsing them, and the individual element is responsible for rendering itself as well. It's an entirely different approach to web development, one that I like quite a bit, but one that required a little bit of additional thinking on my part before I did anything too crazy. Let me show you one more thing here. In my movie view, I give it a tag name of li. This means that it's going to be generating brand new li's every time I call render. When I look at my movie list view, rather than having a tag name in here, I have an element. And if I look back at my index, I can see that down here in this very sparsely populated HTML file, this is my hook. So Backbone can do both of those types of things. Backbone components can either attach themselves to existing nodes in the DOM, or they can generate entirely new nodes out of whole cloth and then attach them to these things. So you can see that my movie list isn't changing, it's always there. But the type of LIs inside of this UL varies based on what particular template I'm using to render this data. Does that make sense? Yes. Excellent. Please.